Please welcome Connor Gilsmith.
Great. Awesome. Thanks for having me, man. All right. Well, thanks so much for having me. It's great to hear all the talk about education, and I'm going to be talking about two-factor authentication today. So I'm sure many people here are already familiar with that, but hopefully you can learn something and take something as well that you didn't know. So I'm going to be talking about this concept of a shared responsibility model and bring it from the cloud into two-factor. The slides will be on my website after, so take notes if you want. And if we have time for Q&A at the end, feel free to ask any questions, but I'm going to hang around all night, so come find me afterwards as well. All right, so many people here work with AWS. It's one of the obviously leading cloud providers. And on their website, they have a page talking about something called the shared responsibility model. And they have this diagram that they present there. And on this page, they essentially break down the responsibilities that they're accepting as AWS, as a service provider, and what the customer is responsible for. Now, AWS takes on the responsibility of the security of the cloud. So they'll do things like run the data center, set up the networking, make sure all the availability zones are running, everything that a typical startup today probably is not dealing with, and they're outsourcing to Azure or AWS or whoever, right? And any of the services they make available, SQS, S3, EC2, all of those are then the responsibility of the customer to use to build whatever services they're providing to their end users. And the key here is that they're responsible for configuring those services to meet whatever security requirements they have. Now, Amazon S3, very, very popular service by AWS, not a surprise to anyone. And it's called out specifically on this shared responsibility model page. And they say services such as S3 are categorized as infrastructure as a service, and as such, require the customer to perform all of the necessary security configuration and management tasks. So if you don't get this right, you can shoot yourself in the foot, right? And this has happened many, many, many times. Probably, again, not a surprise to many people. This is an example of a misconfigured S3 bucket that resulted in 198 million people having their voting details exposed. Dow Jones had a very publicized incident with an S3 bucket. Verizon's run into this problem. And I could go on and on and on with these examples, right? So AWS, as a service provider, many people argued that they had a responsibility to try to fix this problem, even though they clearly set their boundaries that the customer had to configure things correctly, and this was a misconfigured bucket, so the user is at fault. It was happening so frequently that AWS wasn't providing the correct tools to allow the customers to fulfill their responsibility of configuring things the way that they intended them to be configured. So in November 2017, AWS redid their entire dashboard for S3, and as part of this, they now have this awesome, huge warning that says, this is public, don't do this, you probably don't want to do this, don't do this, right? So, of course, this solved the problem and everything's great now, right? Not so. 2018, this happened in Chicago. It also happened in LA. So, though this didn't solve the problem, the takeaway for me here is that AWS, as a service provider, accepted their responsibility to make sure they were providing the best tools possible so that the customers could configure things the way they intended, which is their responsibility. There's still work to be done, but this same concept of a shared responsibility model can be applied in a lot of other contexts as well. So people in this room are probably using AWS to offer services to our customers, and in that context, service providers have a responsibility to offer certain security features, and two-factor is a great example of that. So service providers are responsible, should be responsible, for providing two-factor so their end users can better secure their accounts. And if they do that, then the end user should be responsible for actually enabling two-factor, because if they don't do that, then no one's getting any security from this two-factor feature, right? So I'm going to ask for some audience participation here. I know we've all just eaten, so to avoid the food coma, I'm going to invite everyone to stand up for 1 minute. All right, and we're all going to be seated momentarily through a quick set of questions. Now, if you're a service provider or you work at a company that provides a service, please remain standing. Otherwise, thank you for indulging me. Please have a seat. All right. Still got a couple. OK. So service providers, if your service supports two-factor today, please remain standing. Otherwise, have a seat. All right. So if you know your two-factor adoption rate among your end users, please remain standing. Now, if your adoption rate is above 1%, please remain standing, starting at the bottom. But this 1% number actually comes from June 2016, where Dropbox reported that their adoption rate was below 1%. Hopefully, it's better now. We're not sure. If it's above 10%, please remain standing. All right, this 10% number is from Google. In January 2018, they reported their two-factor adoption rate is just below 10%. Above 28%, all right, still got them. This 28% number is not end user adoption rate. It's a little different, but it's from a survey ran in 2017 by Duo, where they found that less than 28% of people use two-factor. And in that same survey, they found that 56% of people didn't even know what two-factor was before they took the survey. So there's a huge education gap. Above 40%. OK. All right, we got some. Are you in the consumer space or the enterprise space? Enterprise? Awesome. So thanks so much for indulging. And anyone who makes it to the end usually is in the enterprise space. Why is that? Well, you can require your employees to just use two-factor, right?
Mandatory.
You can do that in the well, you can do it in the consumer space, but many people, many services opt not to for a whole bunch of reasons, right? And one of the reasons is that they think it's going to add a lot of friction to their service, and people are not going to use it, right? But in order to get two-factor right, you can't just do a technical implementation. You can't just check the box and say we're done. You have to consider the larger user experience to help educate, help fill this education gap that's clearly out there, right? How are you going to even tell your customers that you have two-factor in your product now? How are you going to convince them to turn it on when they don't even know what it is? So how are you going to educate them about what it is and why they need it, right? So the user experience is critical to get right. But of course, the technical implementation is the first milestone. If you don't have something for them to enable, they can't enable it. And that's where we start. So I'm going to do a quick recap on two-factor. So there's typically 3 factors of authentication: knowledge, possession, and inheritance. Knowledge, something you know, really straightforward, that's a password. Something you have is typically a smartphone, could be a tablet, could even be your desktop computer, or it could be the Yubico like security keys. And inheritance, something you are biometrics, right? Your thumbprint, picture of your face is popular now with the new iPhones. And inheritance, though, typically is not used in context of web application authentication. So today I'm going to talk just about something you know and something you have. So I'm going to run through the 4 most popular methods of two-factor that are out there in the consumer space today, with the goal of helping us understand which of these methods might be appropriate for service providers to implement in their products, so that we're fulfilling our responsibility to allow our users to enable it to fulfill their responsibility. So we're going to talk about SMS, time-based one-time passwords. If you've ever used Google Authenticator, that's what that is. We're going to talk about push notifications. Google's implementation is called Google Prompt. And we're going to finish up with universal second factor, or U2F, which are the Yubico security keys. So I'm going to be referencing this tweet I sent out a while back that has some proposed rankings between these 4 methods. You can see the first method is according to security. And what I was thinking about here was, what vulnerabilities does each of these methods have, and how good a job does it actually do at proving something that you have? Then for the user experience, I talked about how that's really important. And most end consumers aren't using two-factor. So making sure the friction is as low as possible is really, really important. And making sure they understand what's happening is critical to get right. And when you think about security and user experience together, this is where you start to understand which of these methods might be the most appropriate thing for your specific user base. So So we're going to start with SMS, which is right smack at the bottom of the security ranking, but somewhere kind of near the top of the user experience. So quick show of hands. Who here has the ability to receive a text? Right? Everybody. And that's why SMS is so prevalent. But we're going to talk through a lot of security issues that will hopefully make it clear why it's such a problem for two-factor compared to the other methods that are available. So we're going to be following a fictitious friend, Alice, through a lot of workflows today. We're going to start off with the registration flow for SMS. Now, this is pretty trivial, but once she starts the process with her phone number, then the service provider is going to generate a one-time password. And the goal is to have Alice echo that back to prove that she has her phone and complete the process. So it gets sent through the phone company, and the phone company sends the one-time password to the device that's registered with that phone number. Now, I picked my words very carefully there, and we're going to come back to that, but it gets sent to the device registered with that phone number, and hopefully once Alice receives that, she'll type it in her browser, and she's done, right? Now, for the day-to-day login flow for authenticating, it's the exact same flow, but they already have her phone number from registration, so she'll just put in the password and run through the same steps. So there's this big, scary red box around the phone company, right? The phone company is the major source of vulnerabilities for SMS two-factor. And there's two categories that I'm going to talk about. The first are people problems, and the second are technical problems. So we're going to start off by talking about some of the people problems. Did he? He got me. He got me on that one. So whether you call it SIM hijacking, number porting, SIM cloning, SIM swapping, all of these types of attacks boil down to social engineering. Someone is impersonating someone's identity to convince someone at the phone operator to make a change to a SIM card so that text messages don't end up where the end user, Alice, expects them to end up. So after someone has been socially engineered at the phone company, attackers can use a password they've previously stolen to log into the service. Of course, when they do this, it'll generate the one-time password that will get sent through the phone company. And here's where we come back to the specific phrasing. Right? It gets sent to the device registered with the phone number, which is no longer Alice's phone. It goes straight to the attacker's phone. And once they get the one-time password, they put it in the browser, and Alice's account is taken over. This is much more than a theoretical problem, and this happens all of the time. Here's an example, June 2016, where a Black Lives Matter activist had his Twitter account protected with two-factor. They only supported SMS at the time, and attackers were able to social engineer Verizon, make changes to his SIM, and get into his account. In December 2016, attackers used social engineering to sidestep SMS 2FA, and they stole millions of dollars in Bitcoin. Cryptocurrencies and attacking them is just absolutely rampant, and a lot of them have tried to do better than SMS because of a lot of these problems. So you might be thinking, OK, the phone company is the one making changes to these SIMs. They should just do a better job and not mess that up. And that is ideal. That would be nice. But what information do they usually use to verify your identity? Your name, your address, your social maybe. A lot of information that's been floating around online for forever and continues to be breached and compromised thanks to Equifax and all of these other breaches that happen on a regular basis, right? It's not quite that easy. In February 2018, T-Mobile sent a text to the majority of their user base informing them of an industry-wide phone hijacking scam. So if you had T-Mobile, you just randomly got this text to say, things are going crazy, click here, find out more information. Brought you to this page. Right. Yeah, right? Go to this page on their website, and they say, our industry is experiencing a phone number port out scam that could impact you. Clearly, this sounds pretty bad, but they do say, consider checking with your bank to see if there's an alternative to using text for PIN authentication. To me, that sounds a lot like don't use SMS for two-factor. OK, so moving away from some of the social problems and talking about some technical problems. The first is Signal System 7, or SS7. And if you're not familiar with SS7, it's a series of protocols that handles routing phone calls and text messages throughout the global phone network. It was originally created back in the 70s. And when it was created in the 70s, security was not top of mind. It's still at the core of the phone network today, and it still remains inherently vulnerable to abuse. So we'll walk through some scenarios there, but we can see using a stolen password to log in will generate the one-time password, and in this case, in the scary red box, this is where attackers can exploit SS7, redirect the text message directly to their phone, and Alice is up in the upper right-hand corner, totally unaware of what's going on. Of course, once they get the one-time password, they're in. And this is much more than a theoretical problem, too. It's actually been known about for a long, long time. But the argument has typically been that it's expensive, not scalable, and hard to pull off. And a lot of demonstrations, especially in recent years, have proven that to be completely not the case. In May 2016, Positive Technologies exploited SS7 to take over WhatsApp accounts. And WhatsApp accounts not only work with text messages, but they exploited SS7 to do it in the first place. Someone created a company literally to profit from exploiting SS7 and other problems with the phone network to spy on anyone around the world, which includes reading text messages. Here's another good one. In May 2017, attackers exploited SS7 to sidestep SMS two-factor to get into German bank accounts and completely drain them. And this is something that really proved to a lot of people that it's much more achievable and scalable than people have thought in the past. And there are not many solutions in sight. So we're going to move away from talking about technical problems with the phone network and talk about some social engineering problems with SMS two-factor generally. And this is phishing. So phishing attacks are rampant in the industry, and there are not many two-factor solutions that actually prevent against phishing attacks. So we're going to see how SMS is vulnerable. If Alice thinks she's logging into the real Google and provides her password, then the phishing site can turn around, use the real password to log into the real Google. Of course, when they do that, they'll generate a one-time password, send it through the phone network, and in this case, it actually does get to Alice's phone, but she thinks she's on the real Google. And she knows she has SMS two-factor enabled. She's expecting it to get the text. And when she does, she puts the one-time password in, and they're in her account. So hopefully you can see SMS as a delivery channel for two-factor has a lot of problems. And there are other methods that are more secure. So oftentimes I hear people have a discussion and a debate around SMS is better than nothing. And absolutely that is true. If the decision truly is between nothing or SMS two-factor, SMS all day, every day. But there are many of us who have users and customers who can use some of these other options aside from SMS. And as a service provider, I think we have a responsibility to help them make that informed decision because they don't know how this stuff works, right? So the next method to talk about that's more secure than SMS is time-based one-time passwords, TOTP. If you've ever used Google Authenticator, that's how this works, and we'll get into some detail. We'll see why it's a lot more secure than SMS, but does have some usability challenges. So following Alice through the registration flow, once she kicks it off, the service provider is going to prompt her to scan a QR code displayed in her browser with an Authenticator app on her trusted device. And if she doesn't have one, this is the first time she's ever encountered TOTP. She has to go to the App Store and install one. Typically, they'll recommend one to install. And then when she comes back and scans that QR code, this is where the most important thing happens in this registration process. And that is a shared secret is stored on Alice's trusted device. And there's two takeaways for the shared secret. First is that it's shared. So it's on Alice's device, and it's on the server. And the second is that it is secret. It should only ever be on Alice's device and on the server. And if you're thinking, OK, of course, well, it's not going to only ever be there. Someone's going to steal it. Then you're ahead of me, and you're on the right track. But once she scans it and the 6-digit code is shown on her trusted device, she'll put it in the browser and finish the process. So this is a screenshot of Google Authenticator. Many people are probably familiar with this. It has an entry for each account, and it displays a 6-digit code that you have to enter when you log in. And it has a little countdown clock on the right-hand side. It'll generate a new code every 30 seconds. This is a screenshot from my phone as well. You can see I have a bunch of different Authenticator apps. I like to check them out. I'm really deep into two-factor, but normal users only need to have one of these apps. Anything that implements TOTP is going to work for any service that implements TOTP. So the next time Alice comes across a service that supports TOTP, the setup process is slightly easier because she can use the app she already has on her trusted device. So on the login experience, it's pretty straightforward. Alice will put in her password and take out the trusted device, look up the correct account, and put in the one-time password. Right? You might be thinking, OK, she puts in the one-time password, but how does the service provider know that is the correct 6-digit code? And what's happening under the hood is that they're using an HMAC, which uses a cryptographic hash function. And it's not going to be a primer on cryptographic hashes, but there's one critical property that makes this work, and that is determinism. The same inputs will always generate the same outputs. And because the shared secret is on the server and also on Alice's device, combining that with the current time acts as the input to the HMAC, and that's how you generate the one-time password. Hand wavy over some other math details. Right? But essentially, Alice provides 6 digits. Just make sure they match. If they match, you're in. Pretty straightforward, but as a security property, this isn't that great because someone could try to brute force this, so you want to have rate limiting in place. And also, someone could just get ridiculously lucky and guess 1, 2, 3, 4, 5, 6, and if that's right, they're in. So not the best security property, but this is how it's working under the hood. TOTP has its own vulnerabilities. Coming back to the fact that someone's going to end up stealing this secret, it is stored on the service providers, and that is one place you could go and get it. So as service providers, we need to protect this shared secret with the same sensitivity as a password. But we can't hash it like a password and store it in the database because we need to use it as input to the HMAC to generate the one-time password. So instead of hashing it, we're going to encrypt it. And that is great. We can encrypt something and keep it secure. But anytime we start dealing with encryption, we start dealing with key management. So where are we going to keep the encryption key that has encrypted? And you see this turtle down. So the point here, there are solutions to that, right? You could use a hardware security module. You could use a different microservice internally. There's different ways you can architect this. But the takeaway point is that if it's not done correctly, a compromise on the service provider could nullify TOTP two-factor if they get the shared secret. The second place, of course, it's on Alice's device. So Alice might just have her device be her phone, and maybe she loses her phone. If that happens, it's pretty unlikely that someone who finds her phone just on the sidewalk is also going to have her password. So she's likely going to have enough time to go in, reset her two-factor, get into her account, and she'll be good. But the other alternative is that someone already has her password and is targeting her specifically, intending to steal her device to get the secret to get into her account. And of course, Alice should protect her devices with full disencryption and all of that. But this is actually two-factor working exactly as intended. If you launch a remote attack to steal someone's password, but you actually have to physically go get their phone, that is it's a much different attack vector. And that's what two-factor is intended to achieve. Just like SMS, TOTP is vulnerable to phishing attacks. I'm going to sense quite a theme here with phishing for these methods. And just like SMS, once she puts in her password thinking she's on a real site, they're going to turn around, log into the real site, and then they're going to ask for a one-time password. And these phishers are pretty smart. They're just going to turn around and say, hey, Alice, just give us the one-time password. And because she thinks she's on a legit website, and she doesn't know she's getting phished, she's not out to phish herself, she knows she has TOTP two-factor enabled, and she'll just put in the code. As soon as she's done that, they're in her account. It's game over. So I did mention TOTP has some usability challenges. Anyone who has used Google Authenticator, hopefully you haven't had to resort to using your recovery codes. If you didn't print out your recovery codes, you'll have an even worse day. But recovery codes are obviously a common paradigm for a backup method. If you lose your trusted device, you still need to get into your account, right? TOTP actually has another route. During the registration flow, you can use multiple trusted devices to scan that QR code, and then they're all going to generate the exact same code. So this is something that works really well if you can keep track of your devices. But if you don't, and you lose track of your phone, You want to make sure that don't lose your phones. So another counterintuitive thing is if someone is being a good security citizen and enabling two-factor with TOTP on any service that provides it, depending on the app they use, their user experience could decay as they add more and more and more entries to this app. You got to scroll through, find the right one, and then type it in. This is not the end of the world, but users don't want to do any additional actions at all. And the more friction we add, the harder it becomes. Similarly, if you open your app and you see the clock is counting down, you get the first 3 digits, and then you come back and it's rotated. You didn't get the second 3 digits. Now you got to delete, 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 start again. Again, this is not the end of the world, right? But users don't want to deal with this kind of shenanigans. So TOTP does have its usability challenges, but it is significantly more secure than SMS. Even more secure than TOTP is push notifications. And this is a screenshot of a push notification from Google Prompt. If you've ever used it, there's many other services out there that do similar things, but essentially you get a push notification that says, are you trying to log in? Click the yes button if you are. If you're not, click the no button. It is really simple. You don't have to scroll through anything. You don't have to enter anything. User experience here is really nice, but there is some friction getting this set up, and we'll talk about that. So in the registration flow, once you start it, then you're going to be prompted to install an app. And unlike TOTP, where you can have one app that works pretty much anywhere that implements TOTP, you typically need an individual app for each service that you want to use push notifications with. So like Namecheap has their own app, LastPass has their own, Google has their own, and people don't want to go around installing an app for every single account they ever make. And once you install the app, you have to authenticate using your name and password. But after you put in your name and password, what's happening here under the hood is that a public key is being shared from the device to the service provider. And this use of public key crypto is the main reason that this is a lot more secure than TOTP. And we're going to see how this is used. But this is where the public key gets shared with the service provider. Then Alice will get the push notification, click yes, and finish out the process. So on the day-to-day, the flow is pretty awesome. She'll put in her password, get a notification, and there's something really important to understand about this notification. This does go through Google Cloud Messenger or Apple's Cloud Messenger for push notifications, and those are not encrypted. So they can read everything that goes through this push message. So this push message does not include secrets or one-time passwords. It doesn't even include information about the session that they're trying to authenticate. What it does do is prompt the app that's already installed on the phone to mutually authenticate to the service. And once it does that, then it will provide information about what it's trying to authenticate, information about the session. And this is where if Alice taps yes, this is me, what she's actually doing is sending a signed message with the private key back to the service provider. And the service provider can use the public key that it got during registration to validate the signature and have a much, much higher trust signal that this actually came from Alice's device. This wasn't someone guessing 1, 2, 3, 4, 5, 6 and getting ridiculously lucky. So the use of public key crypto here is fantastic. The other great thing is that if there's a compromise on the service provider, the only thing that's getting out are public keys. That's not enough to authenticate into the account. So we've handled the service provider compromise issue. But of course, just like anything, push has some vulnerabilities. Theme, phishing, again. This one is a little more interesting. So once you put in the password, they'll turn around, log into the real site, and this will trigger the push notification to the phone. Now, if Alice clicks yes, game over. They're in, right? But you might be thinking, well, the screenshot you just showed us had some information, like the estimated geolocation, the device, and the time. So there's a chance that she might not get phished. And that is true, but let's dive into that a little bit more. So this is a super scientific phishing site I made locally on my computer, Google spelled with zeros instead of O's. And if Alex comes to this website, doesn't check the URL, is actively getting phished, she might see the Google logo. She's like, great, it looks like Google. I see the Google logo. I'm going to log in. As soon as she does that, she's going to get the push notification. And there is information here, right? If the geo looks off and she clicks, no, that's not me, she can avoid being phished. But let's think about this. She already thinks she's logging into the real website. She knows she has two-factor enabled with push. She's expecting to get a push. It has the Google logo. And like everyone else, she's busy. So muscle memory is going to click the yes button. And as soon as she does that, they're done. Some other usability challenges I already mentioned. You need an app for each service. I won't belabor that point, but it is super frustrating. If someone could solve that in a great way, it'd be awesome. At the bottom, I do point out Duo Mobile and Authy, who are two incumbents in this space. And if a service provider integrates with either of those, their mobile app is the only one their customers will need. But of course, it only works for backends that work with Duo or Authy. So the user experience there is a little nicer, but there's still fragmentation. Just like anything else, recovery codes are the fallback if you lose your trusted device. And that is push notifications. The use of public key crypto, again, is the magic here. It is definitely more secure than TOTP. And the day-to-day user experience of just clicking a button is so nice compared to getting out your phone, scrolling through, finding the right code, making sure you don't have to do any of that. You just push a button. So the last method we're going to talk about is universal second factor, or U2F. I have a security key in my bag, usually have it in my pocket, but I'm sure you've seen them. They're little Yubico security keys. They look like a USB drive, right? And they are unquestionably the most secure method of two-factor, and we're going to talk through why that is. But I put it near the bottom of my user experience because in the consumer space, I think there's a lot of barriers. And the barrier is that you need to purchase this piece of hardware. In the enterprise space, this is great. If you have an IT team, you have resources, you can just say, hand them out to employees, and you're good to go, right? 100% or compliance for two-factor. This is a great way to go. But for consumers, getting them to spend $1 on an app is like moving mountains. Getting them to spend $18 to buy this piece of hardware is going to be really, really hard. And adoption rates for U2F have proven this to be true. But if a consumer did want to do this, the first thing I would do is go to Amazon and type in U2F security key and just see what comes up, right? There's a bunch of different brands that come up, but a consumer who doesn't know what they're looking for is not going to know the brands. They're not going to know the models. They're not going to know, is this going to work for every service out there that I hope to use it with? Is it going to work with all my devices, right? If they just randomly pick one, chances are very high they're going to get a model that doesn't do everything they want. There's a company called Yubico that was involved with creating the U2F spec initially. And their website has this really great quiz that asks you plain English, anyone can understand questions about the use cases that you want to use security keys for. And it will help you identify which of their products is the best for doing everything you want to do. So this is really great, but you have to know this is here, right? The security key I have, I can plug into my computer, and it works great. It costs 18 bucks, but it's USB-A. If I got a new laptop that had USB-C, out of luck. Got to buy a new one. They're out there. You can do it. But now they cost 50 bucks for that model. So we've gone from 18 to 50 bucks. And I still have to get a right model if I want it to work with my phone. There are models that work with the phone, Bluetooth Low Energy and NFC. But that is going to range 50 to 60 bucks. So the consumer, getting them to spend that much money, certainly there are people out there. Many people in this room might already be aware and using these. But the average consumer, like my parents at home sitting on the couch, it's going to be asking a lot to get them to spend this much money. But let's talk about how it works and why it is so much more secure and why you should all go home and tell everyone you know to buy a security key for 18 bucks. So during the registration flow, Alice is prompted to put the security key in her laptop, tap it with her finger, and then the process is done. That's it. That's all she has to do. It's very elegant, but it's hiding a lot of power under the hood. And what's happening under the hood is using public key crypto. And what's happening here is that a new key pair is being generated for each origin and account combination that is being registered. So if we assume we're working with Google here, a new key pair is generated, and it's bound to Google. And we're going to see how that's used, but public key crypto, this is where it gets set up. On the day-to-day, when Alice goes to log in, she'll put in her password, be prompted to put the security key in, tap with her finger, and again, that's it. Very simple, very elegant, but hiding a lot of power and security under the hood. So we're going to run through what that is and how this works. What happens when Alice puts in the security key is that the service provider generates a challenge and sends it to the browser. Chrome has support for U2F. Firefox did not have production support, but there's another spec called WebAuthN. I'll mention briefly at the end, but this is going to be universal in every major browser moving forward, and major players in the industry are trying to make this the new get rid of passwords approach. So after the challenge is sent to the browser will proxy it to the security key. And if the security key asks itself a question, do I have a key pair that is bound to the origin that the browser is currently at, the current origin? If the answer is no, then the process stops, and that's the end. And that gets us two awesome things. That gets us resistance to phishing attacks, because we're not going to have a key pair bound to Google spelled with zeros. It's bound to the real Google. And it also prevents against most man-in-the-middle attacks. So unless you have a certificate and you can host one of these sites on HTTPS, the average man-in-the-middle attack is going to be thwarted by this same exact approach. If a key pair does exist, then the private key is going to be used to sign the challenge, proxy it back to the browser, who gives it back to the service provider, and the service provider is going to use the public key that it got during registration to validate the signature, and if everything checks out, then Alice is logged in. So sadly, nothing is without its usability challenges. This is my desk at home. I work typically in desktop mode, so things get placed. You actually have to have physical access to your USB ports. So again, a trivial thing, but once you actually get access to your ports, you have to have a free port to use. So on the left, I've got my webcam. On the right, I've got my keyboard and mouse. So I have to unplug the webcam, plug in the security key, tap it, take it out, put the webcam back, right? Not the end of the world. But in the consumer space where people don't want to do anything, these kind of frustrations add up. And yeah, not to belabor that point, I can't tell you how much that frustrates me. You might be thinking, get a USB dongle, right? Of course, that's a great solution, but that's spending more money, and I don't want to have more hardware. So, all right, so what happens if you lose your security key? Well, security keys are actually really great because most services allow you to register multiple keys. So you can register a primary and a backup. If you lose your primary, you can go home, get your backup key, you can still log in, and then you can selectively deactivate the primary key. Of course, in the consumer space, this is expecting people to buy multiple keys, which is spending more money, right? This works great in the enterprise. And in the enterprise, too, if you lose a key, you can go to IT. They know who you are. They check your employee, whatever, and they can assign you a new key. And of course, like anything else, if you don't buy multiple keys, you can use recovery codes. So U2F, absolutely fantastic. The most secure method. It is resistant to phishing attacks. It's resistant to most man-in-the-middle attacks. It's not suffering from compromise at the service provider because, again, they only have public keys. And in the enterprise space, it works great. A lot of companies are using this to great success, like Facebook, Salesforce, Google, and they have really fantastic results using this. But in the consumer space, getting people to spend money has proved to be a huge challenge, and adoption rates for U2F are quite low. So regardless of which fantastic method you pick, let's say you support U2F, you have the most secure method, you need to consider the least common denominator, right? And what I mean by this is maybe you support multiple methods of two-factor. You want people who are security conscious, protecting their account with the highest level of security to be able to use U2F. But everyone else who's not going to buy a key needs to have an option, so maybe you also support push or, God forbid, SMS, right? Leaving the decision to the end users who don't understand any of the detail of what I just talked through is giving them the option to choose which method based only on what they know, which is convenience. And they're going to pick SMS every single time because anyone can get an SMS, they understand it, they get it, and I think that's really unfair. And I think as service providers, we have a responsibility to make sure we are providing secure methods of two-factor, and if we support multiple methods, we need to help educate our users so that they understand the choice they're making is not just based on convenience, it also has a security impact. For least common denominator, also think about account recovery. How many people have gone through a recovery process where they're just like, okay, we texted something to your phone, like type it in, right? That's SMS. So if you have U2F on your account, but the account recovery process for the service is still SMS, we're back at square one, right? I mentioned authn in passing. This is a really interesting spec to take note of if you are interested in the identity authentication space. And all the major browsers, I'm not sure about Safari, but Edge, Firefox, and Chrome have all pledged support for this. And it's going to be really interesting to see the next couple years what people are coming up with. So yeah, just to bring it back to the technical implementation, what we're talking about today, as service providers, we have a responsibility to provide two-factor. And there are multiple options. Our users don't understand it, so we need to make sure we're providing the right options for them. But it's not just that. The user experience at large is critically important to get right. And that is a completely different talk for another day. But that's all I have for you guys. So thanks so much for listening. And if anyone has questions. Yeah.
So the most secure option you talked about, is that just an evolution from the RSA tokens that we all had 5 or 8 years ago?
So RSA tokens. I'm pretty sure RSA tokens are actually TOTP. And the reason I say that is that they are? Yeah. They had a compromise on the service provider side. And it cost them like $60 million because all these keys just became useless. They were compromised. So yeah, the other crappy thing about those is it only worked for one service. You had to carry around like a pocket load of these things. No one likes that. TOTP and software is way better. But yeah, those are TOTP based. Yep.
I use push notification with Microsoft Authenticator to sign into Office 365.
Nice.
I discovered on the iPhone, you don't even need to sign in. You can just do a long press on it to approve it. Do you think that's a reasonable security trade-off?
So I'm not sure I understand the context. So you're logging into 365, and where do you do the long press? What is?
It just shows up on the lock
like on your lock screen, and you can.
do a long press.
So you get some different answers on this. According to NIST guidance, that's like a huge no-no. They want you to security in layers, right? And they say if you have a mobile device, you should have a lock screen, and you shouldn't be allowed to do that. So you can just pick up a device. Yeah, I mean, is it more convenient? Sure, I guess. But with an iPhone now where you can just put your finger on it, like, are we really saving that much time? I personally would say no. I'm not a huge fan of that. Opening the phone proves that you have your finger or have your PIN code or whatever. So it does help. Yeah, but question in the back?
Yeah, it's funny you mentioned that push was one of the most secure. We just did a review and we kind of said, hey, we don't want our users to use push, and the reason was if someone did a password spray against our environment and had like 10,000 passwords, you know, the chance that 100 users or something would just be in a bar and click approve is pretty likely. So we thought like SMS diverting a ton of our users, like text messages versus like a bunch of people accidentally clicking approve because they're already in their email or they're not paying attention would be higher. So
This
I was
is
just
a
wondering.
corporate decision.
Corporate environment, yep.
Wrong decision.
Okay.
Do you use a PBX that's a physical PBX, or do you use a PBX in the cloud?
What are you referring to in terms of?
I bet that you have office phones, and I bet 90% of your people forward their office phones to their cell phones. And I bet that somebody could take over your PBX and basically take those SMS messages anyway across your entire environment. And if you have, and I'm not trying to be a jackass, but I'm going to be honest here, it's your fault if they hit yes on those phones because you haven't educated them all.
Right. So yeah, we did educate them.
Another thing for that is that there's a lot of other things you can do for authentication. So in that, like, expecting users to have good passwords, I mean, we know that's all a pipe dream, right? It's not going to happen. But you can educate people to have better passwords and give all of your employees password managers. So that's going to help a ton. And then also, there's buzzwords flying around, but like dynamic authentication or adaptive authentication is something where essentially people will take into account additional things like geolocation. Like if I'm logging in all day from here and then someone logs in an hour from now in China, they're like, that doesn't seem right. Maybe we're going to not let that one through. Or prompt for some other kind of two-factor. So I think there's a lot more you can do on the back end of the service provider to try to help with that. But I mean, to your point, if people aren't educated and they're just clicking yes, then it could be an issue. Yeah.
And what percentage, I saw you showed Google Authenticator, showed the location, the user agent, for the user logging in. I haven't seen too many products other than Google in the enterprise space show the geolocation.
Yeah, I'm not sure what Duo shows. Duo is arguably the leading incumbent in the enterprise space, Authy in the consumer space. And the number of people who work with Duo, I mean, they are just rampant in the education space too. I'm not sure what they show. If they don't show geo, maybe they should, but these phishers are smart. If they're doing a spear phishing attack and they're targeting a small group of people, they can easily set up boxes wherever with a cloud and just pipe it through there. So, you know, users who look at that think, oh, this is definitely coming from this place, but we all know that's dubious. So it's of limited help, I think. Okta is?
Yeah, Okta and WatchGuard just acquired Cannonball.
Okay. Yeah. I think it's better than not showing it, certainly, but it's, yeah.
In the last few months, Hotmail and Outlook.com have added a new feature to their push notification that has a 5-letter code, and it says when you sign in, it should match the code that appears on your phone, which is a new wrinkle that you didn't see in your slides. Interesting.
Yeah, I'm not familiar with that. So you would log in, and then they would show you the 5-digit code in the browser?
Yes.
A phishing site wouldn't have that.
A good phishing site would, right? I would scrape it, turn around, and
yeah, on your computer.
Yeah. So, sorry, say it again.
If I was to try to sign into Hotmail on your computer right now, it would say sending this code to your device.
Right.
And on my phone, it will have the matching code if it's legit.
I mean,
that, of course, requires users to be mindful of these things.
But also the problem is that a phishing site, anything that's shown in the browser that's not like cryptographically bound to that session, I'm just going to turn around and scrape it and then put it in my phishing site and say, hey, you're going to get something that says ABC123. If you don't, shit's crazy, but here you go, right? So there's a project I've been working on that has a web extension. We're out of time, but yeah, there's things you can do like being built into the browser that allow you to try to address this phishing problem. But if you're not running software in the exact session where someone's running in to make sure that it's the same origin that was registered initially, phishing is going to be a huge problem. So I need to learn more about that. I'm not familiar, but I got to read up on it. All right. Well, thanks so much, everyone. I really appreciate it.